Hello again, and welcome to episode 3 of the series in the Virtual Sensor Extended Functions. This one is going to look at the special GPS functions built into the app. Now, if you're using a transmitter with a color screen such as this one, can I very strongly recommend that what you want to do is use Dave McQueenie's Maps app for no-fly zones. It is vastly more powerful and a lot easier to set up and can cope with no-fly zones of all sorts of shapes and sizes and locations. The reason it's been built into this app is because the app can run on the original 14 and 16 transmitters with a monochrome screen, and it therefore gives them a little bit more ability than they already have to do no-fly zones. But we're still talking very limited. In other words, you've got circular zones, which can be no-fly inside or no-fly outside. And the zones can have a sort of straight line cutoff on them to make them into semicircles. And you can set up a few of them, but it is, as I say, very limited in what it can do. But it gives you, with the monochrome screen, a little bit more option than you had before. So let's go in and have a look at what we do in the app. Well, the first thing you do is come down to GPS sensors and tell the app where it's actually getting the GPS data from. There's a drop-down box for each of latitude and longitude. If it hasn't already filled it in, go in and fill in each one. Just choose the relevant thing, and there we go. Now the app knows where to get its data. The GPS points, it should, with any luck, have come up with one to start with. And this is going to be point number 1. And the app will also treat this as the home point. You'll notice that we've got 2 reset buttons. If we press reset, as in other sections of the app, it will wipe everything out and you'll have to start again. Or you can just reset point number 1. You can use plus to create more points, numbers 2, 3, 4, and so on. Point number 1 may be the only one that you want to reset because that's being treated as the home point. The other points that are created would be points at various airfields or multiple no-fly zones around an airfield. And this button here will do 2 things at the same time. It will create a new point, same as pressing plus, but it will insert the latitude and longitude of the point where the GPS is at that moment. So you could walk it out to a particular location, press that, and it will create a point of that location. Otherwise, pressing plus creates a point, but you then manually have to input the coordinates which you'd find off, for instance, Google Maps, Google Earth. I'm sure there are plenty other places you could get it. And they must be in the 6 decimal places format. Now, unfortunately, we're just going to have to talk technical for a moment about the home point and the origin and the different GPSs you can get. All of the GPS receivers that I know of, such as MGPS, which we're using with this, and the one you can build for yourself from RC-Thoughts website, or what else we got? Powerbox GPS, and the MavSense GPS, whatever. They create a home point, and that's actually created and stored in the GPS sensor itself, not in the transmitter. Jeti calls it the origin, and it's from that point that it measures several things that you can get through telemetry, such as when it says distance, it means the distance from that origin point to where the GPS sensor is now. So you could, get it to tell you how far away the aircraft is at any point. Bearing, in other words, on what compass course from that origin to where the model is now. So this origin, we'll call it, is an important point. It's created by the telemetry sensor, it's stored in the telemetry sensor, and the telemetry sensor does the calculations and of things like distance and bearing, and sends it back to the transmitter as a telemetry value. Jeti's MGPS has an important difference to all the others. All of the others that I'm aware of set the origin when it first gets coordinates after you switch it on. So you switch your radio on, and after 5 seconds, 30 seconds, whatever, it finally finds the satellites, works out where it is, bingo, it uses that point as the origin. Jeti doesn't, which is a double-edged sword. On the one hand, you can then use a different location, but on the other, if you set your origin at the previous airfield you were at and you've come to a new airfield and you forget to reset the origin, it's now trying to tell you distances and bearings from the other airfield, which could be, for me, anything up to 90 miles away. And this can be irksome, so I will put a link in the description box below to my video that shows you how to program your radio to get the Jeti one to automatically reset the origin to where you are now. Okay, but whether it's the Jeti one or the others, the point is that the origin is made and stored in the GPS sensor. And when we're talking here about point 1 being the home point, this is a home point in the transmitter. And the other points that we create will be stored in the transmitter. Yes, it got it from the GPS, but it's independent of the origin that's in the GPS system. Now, I appreciate that this is a bit, oh God, what's he going on about? But it is important to understand the difference between the origin that's in the GPS and the home point that the app is using, because they may not be the same thing. They may be the same thing. They may differ, and you can manually make them differ. They may differ by just 10 feet, from where you switched it on to where you've reset. That's fine. It's not going to make much difference to anything. But it is important to be aware of the difference, especially with the Jeti MGPS, which, if you haven't manually reset it to where you are now, it could be working at an airfield tens or hundreds of miles away. So what I'm going to do is just show you creating a new point with new lat and longitude. I'm just going to press this button and it'll create point 2, and it's picked up a latitude and longitude. Of course, I've blurred them out so you can't see exactly where I am, just for security. But you'll have to take my word for it. The numbers in point 2 are very slightly different to the numbers in point 1, because I had the GPS unit outside when we reset number 1, and I'm now in the workshop for number 2. And if you want, you can press plus, as I said, manual create more, type them in. If I press reset 1, number 1 will remain, but it will reset to where the GPS is right now, which has moved by a few feet from outside to inside the shed. If I press reset in total, it clears out all of them except point 1, and point 1 now resets to where it is at the moment. That's how those work. Let's create a point 2, so we've got something to work with. And a point 3, which remarkably is looking exactly the same as point 2, as it should. Say OK to that, and we come to the result expressions. I'll reset that for the moment. So we press plus to create. Just before we do it, I'll tell you, head into the help, because there is a lot of information there about the help, about the GPS. Starting here, it tells you about 2 special functions, GPS D, which is distance, and GPS B, which is bearing. It tells you all about them there. And then Dave has created another 2 special functions for no-fly zones. NFI, which is no-fly inside. So you would set up a zone and it would warn you if you're about to go inside that, because that's the forbidden zone. And there's NFO, which is no-fly outside. So you could set up, say, a circular or semicircular zone around your airfield center point, and it would warn you if you're about to leave that and go outside. And these tell you how the mathematics is set up and how you put data into them. So press plus to create. The first one we'll use is the distance one. So let's find that. GPS distance. Open bracket. And now you put in the number of which point you want it to calculate the distance from. If we put in 0.1, it would be the home point, which is picked up by the app from wherever it gets the first good coordinates after you've switched the radio on. So you change airfield, this will work fine. Even with a Jeti MGPS that you haven't reset its origin, this app is going to work off 0.1, and 0.1 in that list of coordinates takes its data from where you switched on and it first got good data. So you could say GPS D, then we want 0.1, close the bracket, and that's it. And it all works in meters for this, so it thinks at the moment the GPS is 15, it's jumping around 12 meters. And the reason we're getting, a bit fiddly data is I'm inside a workshop which is well insulated with that sort of aluminumized bubble wrap, and it's struggling to see the satellites. So GPS D 0.1 will return that. We could select any of the other points. Close brackets. Remember we created 0.2 and 0.3? So you can build up functions telling you distance from various points. And if we take that out and select GPS B for bearing, we do the same thing again. So GPS B, the bearing from whatever point you want, 0.1, that's its bearing from there at the moment. Or it could be 0.2, 0.3 or whatever. Okay, on their own, there's not much you do with distance and bearing. The difference from this to what you can just get on your telemetry data of distance and bearing is that here you can select which point it's from rather than it just being the GPS's origin point. So now let's take that out and have a look at what we can do with the likes of the no-fly inside and no-fly outside. Now what we'll do is build up a no-fly outside first of all. And so we take result 1. There. No-fly outside. And inside the brackets, we're going to put two different numbers separated by a comma. The first number will be the distance away from the home point. So if you had, say, a 200-meter radius from your pilot's box, wherever you can fly around, you can do that, comma, and then GPS point 1, 2, 3, 4, whatever. But if it's GPS point 1, which is the app's home point, and in most cases it really is going to be that, you don't need to put in the point number of it. So GPS points 1, 2, 3, whatever. If we leave it blank and just close off the bracket, it will work with a circle radius 200 meters around point 1. And if you're inside it, it gives the result 0. If you were to go 200 meters or more beyond the app's home point, 1, or whichever point you've selected, the result turns to 1. So it gives you a switch output, and you can therefore use that to trigger a warning. Well, that's a simple circle, but in most cases you can't fly in a circle all around you. You might fancy having a particular cutoff to the area behind you. And what you can do, therefore, is add a little bit more into this. And if you look in the help screen, scroll down to the bottom, it does actually list all this formula for you, so you can see what you're doing. So what we can do is say OR, and we're going to create now a compass bearings either side of 0.1, which if it exceeds those, it will also return the value 1 to say you've exceeded them. Let's take the example that you are facing directly south, heading of 180, and you are allowed to fly directly out to the east or to the west, so those are round through to headings of 90 or 270, but you're not allowed to fly to the north of that. So basically you're trying to create a semicircular no-fly outside, and we can set up the bearings for that. So we're going to say OR absolute, and then the central bearing for the direction in which you're allowed to fly. So let's say you're facing south, which would be 180, minus then GPS B 1, you want to specify it, or whichever is the GPS point you're interested in. Couple of close brackets,
no-fly zone,
and then greater than 90. Okay, so what this will do is 180 minus your bearing, and then effectively, because of the abs, it converts it to a positive number. Is it greater than 90? The result will go to a 1. If it's less than 90, it'll go to 0. So imagine you're facing south, 180. The model is out on a bearing to you of 100 degrees, so it's a little bit south of the bearing east. 180 minus 100 would be 100. Is that greater than 90? No, it's 180 minus 100 is 80. Is that greater than 90? No, it's not. Result 0. But if the model was on a bearing of 80 degrees from you, which is into its forbidden zone, then it'd be 180 minus 80, that's 100. Is it greater than 90? Yes, it is. Result 1 would go to 1. What if it was swung round the other way at 260 degrees? Well, 180 minus 260 would be minus 80. Convert that to a positive, it's 80. That's less than 90 degrees, so it would still say you're okay, you're at 0. But if it was at 280 degrees, the result would be 100. Is that greater than 90? Yes, it is. Result would go to 1. So this bit before the OR will provide you with a circle of 200 meters radius from the home point, and if you go outside that, it's going to switch to 1. Or if you come north of these, the result of this equation, it will also go to 1 and tell you you've flown outside. So set your central direction that you're facing here, and in this, the shape of the no-fly zone. If you were allowed to fly in front of you only 45 degrees either side rather than 90 degrees either side, so you're only allowed to fly in, say, a quarter segment of the circle out in front of you, you'd set that to 45 degrees. So the number of degrees either side of the central way you're facing, and that will do its job. Then what you can do is come to the announcements, plus to create result 1, that's, remember, equation 1 we've done. Periodic, no, it would be on an edge. Edit it.
Entering no-fly zone.
Choose your audio. Entering no-fly. No-fly 1, no-fly 2, no-fly 3, no-fly whatever. You can also have leavings if you want. So you'd select, for instance, the one you want. The edge trigger direction would be rising from 0 to 1. Stick shaker if you've got a 24, and your enable switch set to log max to make sure it's always working. And then if you flew outside that semicircle that's allowed, or quarter circle, or 2/3 circle, because you can set it greater than 90 if you want, it will tell you. Okay, let's take that out for the moment. Take out that announcement. Come to results expressions, reset that, and now we're going to look at the no-fly inside, because this is where you can really use it with lots of the GPS points that you create to create them no-fly insides for multiple different airfields. Remember, the no-fly outside is generic to every airfield you go to. So if you're swapping airfields, you're going to have to change the distances or the bearings in the equation for each one. Remember what I said is if you're using the transmitter with a color screen, just don't even bother with this. Go and use the Maps app. So what we do is choose NFI, and again we're looking for 2 numbers within the brackets. The first number will be the distance of proximity to the number of the point that's the second number in the brackets. So if we want to get a warning when we are within, let's say, 150 meters, comma, and really you would be expecting here not to use 0.1, because that would tend to be your home point pretty much where you are, but points 2, 3, 4, 5, 6. So this is where you can set up multiple different no-fly zones suitable for lots of different airfields, and it doesn't matter. You don't have to set them up for the airfield you're specifically at and keep amending them. You can set up different ones for different airfields, because it's only going to be bothered if it actually gets to that distance to that point, close brackets. And if that point is at some airfield 100 miles away, it's just not going to bother the app. So this allows you then to set up different ones for different airfields, whereas the no-fly outside really best works only with the home point at the airfield you're at. And so that concludes this look at what you can do with the GPS equations in the app. And so you can do just a little bit more with it than you can do with the simple distance warning that you could in the Jeti telemetry switches. So have fun with that.